All right, I just realized that I didn't put the model up here. There's only one problem, but it's pretty extensive. So you have data, and they say that this is cyclical data, and if you plot it on Excel, you'll actually see that it looks like a periodic function. The intent of this problem is to model this with what we call a periodic function. There's two that you know of. They're really the same, actually. So A times cosine of B x minus c plus d. Maybe I should put a times here so that you can see that there's actually something in between. So this is what it looks like. And so what they want you to do is just estimate these parameters. So I'm going to go through with you how to do that on Excel, which is the surest way to do this cleanly. And I also want to point out this is exactly what you want to do for the DLA individual part. So this is a great exercise to get you ready for the individual part of the DLA, which I, in my opinion, is a little involved. All right, so let's look at this. You have data. What I did is I first took this data and I copied and pasted out of WebAssign into Excel. It wouldn't let me copy and paste directly, so what I did is I copied and pasted into a program called Notepad. So you see the X's and Y's, and then I went, there was, I think 8 rows, so I went and highlighted 8 rows on here, and I copied and pasted it into here. Or you can type it directly, it doesn't matter. It'll save you a lot of time later. All right, so, first I took these two and I scatter plotted it. So you highlight these two, you go to Insert, and go to Charts, and I always select this one and you see it scatter plotted. So I didn't make these graphs look fancy. Here it is, and you see it's periodic. So the first question is, how do you estimate A? This is called the, I realized you probably couldn't see what I did. So I copied and pasted the data. You can type in the data, highlight the data, go to Insert, go to Charts, go to this, and you'll see the graph. So how do you get the A? Let's start with the A. Well, there's a formula for A, and the formula for A is called the amplitude. It's the how high this thing is spinning up and down, and it's the maximum, it's an estimate. So I have a little approximate symbols here instead of equals because this is real data and we don't have equals in real data. It's just approximate. You take the maximum height that you see and your minimum height that you see and divide by 2. So if I look at the graph, the maximum value is right here and the minimum value is right here, around x equals 6 and x equals 12. So if I go back to the data, I see that x equals 6 is right here and x equals 12 is right here, But I'm not going to do it that way. I actually have a formula. Here's the formula. Equals the maximum of B2 colon B8. So all the data of the y value sitting here. B2 to B8. So the A value is maximum of this minus minimum of this, the same command. Make sure you close all your parentheses. You see that the red parentheses represents the colon part and the other black parentheses are the outside part, and you divide that by 2. Boom, it gives me the 28.6. And if you go back and look at the answers, 28.6. Pretty easy. So that's what I get for this. Oh, I don't, somehow I lost my minus sign in between the two. The period looks like it's about 12 months. I can see that. How do I know that? It does one cycle, returns, and then it starts doing the same thing again. So this length here is about 12 months. If you go back to the beginning, it says the period is 12 months. So that's what you put there. How do you find B? In this formula that's right at the beginning that I showed you. How do you find this value of B right here? That's the next thing up. So here's the trick. Ignore the C stuff. Just look at this without the C. B is called the angular frequency, how frequently it wiggles up and down. Set that inside of the angle to your period. I use T's here instead of X's. I always think of the X value as being time, but set that angle with that period length, which was 12, equal to 2 pi. So B, because the actual cosine that you learn about in high school is period is 2 pi. So you want the inside part, your period, to be 2 pi. And so you're actually solving for what value of b would make that happen. And so when you do that algebra, I got 0.52. And so go back here and you see I got 0.524. I guess I should have rounded it a tiny bit more. All right, so that gives us b. All right, so next thing, vertical shift. So if you go back and look at this graph that I have in Excel, it's not exactly, the cosine and sines wiggle around y equals 0. They'll oscillate around y equals 0. So mine oscillates somewhere else. It looks like it oscillates up here somewhere. How do I find out how much to lift my graph by? Well, that's called the vertical shift. And what's nice is in your book, they have estimates for it. So the maximum value of the y minus the amplitude yields you the vertical shift. And these things will be inside your, they should be inside your T-sheet that you make. And also you can use these same ideas for the DLA individual part. All right, so if you go here, if I go to D, I just take, again, I use the same formulas. I take max of B2 to B8, because that's where my data lies, and subtract the amplitude, which is already done. It's in E2, and I get 59.4. If I go back to the solutions that are on my key, which will be different for you, actually, it's a little bit further down, you see 59.4. So you can crunch this out pretty easily. Then it asks you, last thing is for the horizontal shift. That's a bit tricky because that's what I did is I plotted the actual cosine without a horizontal shift and my data. So I want to show you what that looks like in Excel. So this is what it looks like without a horizontal shift. So I don't have any C's in here. And all I did is I plugged in A, which is an E2, cosine B, which is an F2, and times the X value, which is an A2, and added the D, which is the 59.4 in G2. Notice that all the parameters, like in the old days, have dollar signs on them because I don't want those to scroll. I only want the X to scroll. And I scrolled those down, and then I highlighted all three values, all three columns, and I just told it to plot. So I went up to Insert and Plot. And so that's what I get. So the blue curve is my data, and the orange curve is the unshifted without the C. And so I look at how off are they from each other. I could just take it, my data, it's supposed to peak here, and the unshifted one peaks here. So how much would I have to slide it to the left? That's really the question. Well, I can just look. How much would I have to slide that to the left? It looks like it's about 6. Unfortunately, you can actually try to solve for it, but it doesn't really do a good job on Mathematica. So it's reasonable to say it's about 6. It turns out that the exact answer is 2 pi. And I don't know how you're supposed to get that without actually solving. But my guess is that you probably have 2 pi as well. In real data science, 6 would have been close enough. And so I just went to Excel again, and I just checked what it would look like if I had plotted it with 2 pi, and I'm going to get rid of this so you can see. So this is my one with C in it. I just put 2 times pi here, subtract it off. So same exact formula as I had over here, but I now have a shift by 2 pi. And I just scrolled those down. And then I plotted all 3 of these together. So all you have to do is go back to back, highlight them all, go up to Insert, Charts, and you see like the gray curve is now my estimated curve, and it fits the blue curve pretty decently. So I can see that, yeah, it looks like it's about a horizontal shift of 2 pi. And this is how you should check your work too, to make sure that everything is matched up. So again, for the DLA, you're going to have some similar things. You have similar data. You'll put it, you can actually type it in manually to Excel and do exactly the same thing I'm doing here. And if you want this Excel file, you can ask me for it. So just email me and ask me for this Excel file. I'm going to go save it right now. And this is lesson 47.